A cool Clausen integral. So we have this integral from 0 to pi by 2 of x log of sin x dx. And let's see how we solve this. And for information, if you just don't know how Clausen integral function is defined, CL2 of theta is defined as the integral from 0 to theta of minus ln of 2 sine x by 2 dx, or this is just defined as, this is same as the sum from n equals to 1 to infinity of sine n theta by n square. Okay, these two are actually the same definition, and both are the definition of Clausen integral function, that is CL2 of theta. Now, using this information, let's try to solve this. First of all, I guess we need to use the integration by parts. Yeah, or maybe first of all, let's try to make this y by 2. So let's say x is equals to y by 2. Yes, and then we get integral from 0 to pi by 2 of that x is y by 2 log sine of y by 2, and then dx is dy by 2. Okay, good. Now we get 1 by 4 in front, 1 by 4, and then integral from 0 to pi by 2 of y log sine y by 2 dy. Yes, cool. Now let's try to make this 2 sine y by 2, because that is the standard form where you can use Clausen integral function. So 1 by 4 integral from 0 to pi by 2 of y. And also I forgot something. Since we have taken y equals to 2x, so the limits of integral also changes, and this becomes pi actually now, pi. And over here also this will just be pi now. Okay, good. Now it looks good. Okay, and y, and this is just log of, again I can say this as 2 sine y by 2, but I also have to subtract log of 2. Yes, dy. Now this looks good. 1 by 4 integral from 0 to pi of y log of 2 sine y by 2 dy. Yes, and then minus 1 by 4 integral from 0 to pi of y log of 2 dy. Good. Now I can integrate this easily. Yes, this is just minus 1 by 4 log 2 minus 1 by 4 log 2 integral of y is just y square by 2. Yes, from 0 to pi. So this is minus 1 by 4 log 2, and then pi square by 2. Yes, and minus 0, that will not be considered. Okay, and over here you can use integration by parts again. So 1 by 4, and then y times integral of this thing is, actually integral of that thing is CL2 of theta if we have minus sign, but since we don't have minus sign, this will be minus CL2 of theta. Yes, minus CL2, and this is actually an indefinite integral as well, and this go evaluated from 0 to pi minus. And if you want to know why this is the indefinite integral, what you can do is you can just differentiate both sides with respect to theta, and then you will see that with respect to theta you will just get minus ln of 2 sine theta by 2, again and then plus ln of 2 sine of 0 by 2, and that is just 0. Second part is just 0, so this is also the independent integral. Yes, and now minus, and now this goes to 0 again. If we evaluate this, that will just be minus CL2 of theta. Yes, and d theta, this goes from 0 to pi. Good. Now this is 1 by 4. Okay, 8 pi CL2 of pi is just 0, and at both points this is just 0. Yes, isn't it? The CL2 of, because CL2 has pi in it, because CL2 has pi in it, that will just be 0 in both cases. Yeah, okay, good. I'm going good. Again, n plus 0. Now this is plus integral from 0 to pi of CL2 of theta d theta. Good. Now after this, what I can do is now to integrate this. We know that the sum for CL2 of theta is sum from n equals to 1 to infinity of sine n theta by n square. Yes, and d theta, and minus this is 1 by 8 log 2 times pi square. Good. Now we can interest in the sum and integral and then integrate. Yes, if we're interested in the sum and integral, we have 1 by 4 and then 1 by n square, sum from n equals to 1 to infinity. Integral of sin n theta is just cos n theta by n from 0 to pi minus pi square log 2 by 8. Okay, good. Again, now this is 1 by 4, sum from n equals to 1 to infinity, 1 by n is n cube. Now cos of n pi is minus 1 to the power n, minus cos of 0 is just 1. Yes, yes. I'm not sure if it's going to give me answer or not, because oh wait, wait, this is sine, and this will be minus cos theta. Yes, so this is now minus 1 to the power n plus 1 plus 1. Oh, good. Now I think it's going to give me answer. Okay, now this will just be 1 by 4, and if it's plus okay, so this sum will just be 1 minus 2 by 2 cube zeta of 3, and the other sum will just be zeta of 3. Yes, and this is minus and the other part is just minus pi square log 2 by 8. Let me make sure the second part is corrected, not minus pi square log 2 by 8. Okay, yeah, that's correct. And now this is just okay, so 4 minus 1, 3 by 4 plus 1, 7 by 4, and this is 7 by 16 zeta of 3 minus pi square log 2 by 8. Okay, good. So this is a good answer. 7 by 16 zeta of 3 minus pi square 8 log 2. Yeah, so that is the answer. Yeah, so if you have talked about the flow of the solution, we just took it to the form of Clausen integral function, and then use integration by parts, and then use the sum definition of Clausen integral function and integrate it, and just use the sum of the zeta functions. That was it. It wasn't too hard. I hope you understood the solution. Thanks for watching, and look forward to seeing you in the upcoming videos too.